Welcome back everyone. In this video, we will learn how to model pump nozzle using rigid arm technique. In last video, we finished modeling our first pump here using anchor method and rotating equipment method. Right now we need to insert our second pump here. In order to do this, we will go first at this point and we will insert a new segment which will be called H, but it will be connected directly to D06. So once you press tab, this is already disabled now because the software knows already the coordinate of D06. You press OK. Then you will start inserting a run, but first, when you are pressing here, you need to make sure that you are not selecting D, you are selecting the segment H. You can make sure that by looking at here, you can see right now that you are selecting the segment D. You can use your arrow up and down in your keyboard to switch between D and H. We will start right now modeling in segment H by inserting a run. This run should be half of the distance between D and G, or whatever the distance between D and the pump, then G, because maybe it will not be exactly in the middle. So right now we are just considering that it is in the middle, so the length will be 1000 millimeter in this direction. Okay, then we will insert another run, but the name of the second point, it will not be H02 because we wanted to connect directly with G00. So this will be G00, and the same, this is disabled because the software knows now the coordinate of G00. You press OK, and now you have this segment. You will go to the midpoint or the pump point, and you will insert an anchor with 0 displacement this time, and you will go to select. You will select segment, and you will press here because you want this H segment right now, which is going to be the rigid arm connecting for pump number 2 between D06 and G00, which are the pump nozzles. So we will go to insert and we will go to rigid options over range. We don't want to include weight because this will be the pump, and we want to include the thermal expansion to replicate the thermal expansion expected in the pump nozzle, and we'll press OK. We will go back to select and we will clear. You can see now this new purple color over this segment, which is indicating that this part right now is a rigid option. After that, you will select this point D06. We will go to insert. Right now we need to insert reference points for the pump nozzle at both suction and discharge sides. We need to do this because we want the software to compare our forces at the pump nozzle between the actual and the allowable moments. In order to do that, we will insert a reference point with specific allowable forces, and so the software will compare between the actual and the allowable forces for these points. We will go to D06 and we will go to insert. This is reference point. If you can't find this icon at any time here, you can go for this command search utility. You can insert reference point and you will see it here. Whatever any order you are looking for, you can find it from here. We'll press reference point. This, we want loads acting toward H01. No, we want loads acting toward D06 because D06 is the pump nozzle. Report actual loads and report allowable loads also. Here is the allowable loads where we are going to insert our maximum forces in X, Y, Z and resultant, and maximum moments X, Y, Z resultant. You can always look here to know the units which you are using. Let's insert right now any values. These values you need to get it from the manufacturer of your pump, like we explained earlier. These are just any random values right now we are inserting just for the purpose of modeling. We press OK. Then we will repeat the same sequence for the point G00. We will press again insert, reference point, loads acting toward G00, allowable loads, we press OK. Now we have this support is indicating the support of the pump, and we have this rigid part here is for the pump nozzle, and these 2 points we have reference point with specific allowable forces, which is the software is going to compare the actual forces to the allowable forces imposed after we run the analysis. So that's it for our video today, and see you in our next video. Thank you.